We're doing question 7 now, 7.1.3. The question says, on January 2014, NOMSA invested 2 million in an account paying interest at 10% per annum, compounded monthly. Okay, NOMSA withdraws a fixed amount from this account at the end of each month, starting on 31st January 2014. If NOMSA wishes to make monthly withdrawals from this account for 25 years, calculate the maximum amount she could withdraw at the end of each month. All right. We are looking for, the maximum amount she could withdraw at each month. Okay. So now, if you use the present value formula, which is given by right here, so 7.1.3. So here we're looking for X, the money that she can withdraw each month, and the formula will be given by P, which is equal to X, open square bracket, 1 minus open bracket 1 plus I all to the power of all to the power of negative n. Okay, I'll move it a little bit. Right, not to the power of negative n all over I. Now we're looking for X. So the present value, she invested the question says she invested 2 million. Let's see here. She invested 2 million in her account that pays 10% interest. So now we're going to start in these values. 2 million is that the money she invested, so the present value, this will be 2 million equal to X. X is unknown because we don't know that the money she needs to withdraw every month yet. So it's going to make 1 minus open brackets 1 plus I, which is 10%, so meaning 0.1 over 12. Okay, because compounded monthly, all to the power of negative. The question says n, negative n. What is n? When you look at the question here, the question says that make monthly withdrawal from this account for 25 years. So n is 25 years, 25 years meaning 300 months, because we do 25 times. So I'm gonna write here 25 times 12. Okay, so this will be 2 million will be equal to X, in brackets here, 1 minus 0.1 over 12 to the power of negative 300. Okay, all over, I can put all over I, so 0.1 over 12 there. Now to find X here, we can just keep X over here and then multiply 2 million by the inverse of this fraction, by the inverse of this fraction. Okay, we're going to multiply 2 million by the inverse of that fraction. So it's going to be, that's how we can find X, because all this is product. It's like we're going to do 2 million, multiply that by, okay, I think I'll need some space. All right, 2 million, no. But X will be 2 million multiply this by the inverse of what is in yellow here. So it will be 0.1 over 12 over, excuse me, 1 minus 0.1 over 12 to the power of negative 300. And then this now, we're going to place this in the calculator as it is, and we can guess the amount of 18174.01. So that's the value of this. Or else we can equate these two formulas. Okay, we can also solve it this way. We can wake up because the money is compounded monthly. We can say 2 million. Okay, 2 million. Because it's compounded, it's going to be 1 plus 0.1 over 12. Okay, all to the power of 300. And then this will be equal to let's just make equal sign. I'm gonna move it a little bit. Move it this way because I used the formula that says all this is like the amount, okay? All this is the amount. The amount is given by P open bracket 1 plus interest all to the power of n, okay? And interest, you know, is the rate over n, and n here we times by 12, okay? So let's say all this, that's the amount. This must be equal to, move it over here. The future value formula will be what? X open square bracket, then we do 1 plus I to the power of n minus 1 all over I. Okay, so now we sub in there, that's the future value. So this is going to be equal to I'm gonna write x, okay, open square bracket 1 plus I, which is 0.1, so 0.1 over 12, so 0.1 over 12 all to the power of n, which is 25, right? 25 is like, it's 25 times 12. 25 times 12. Maybe I should write also here 25 times 12 to make it 25 times 12. And then minus 1, we close the square bracket, all over I. I is 0.1 over 12. So all this is just the future value. Now, we're going to equate the two, okay? Now this will be, we can just calculate this, and then if the two are equal, what we can do, we can cross multiply, or in short, we can just take whatever we got in this fraction here, in this fraction over here, we reverse the fraction with times but with the other product. So it's going to be like 2 million 1 plus 0.1 0.1 over 12 to the power of 300 times by 0.1 over 12 all over 1 plus 0.1 over 12 to the power of 300 minus 1, like that. This is equal to x. So now this will make that x to be equal to 18174.01. Thank you.